All right, so this is my first screen share video, so we'll see how it goes. Looks like I would just press this blue button and stop sharing. Okay, so on that note, we're going to go ahead and start taking a look at the parallel postulate. It's a little blurry because I had to screenshot it. But anyway, parallel postulate says that through a point P, which we have on the next slide, not on line L, so just a random point, there's exactly one line parallel to L. So um, hopefully we get that because, of course, if there was any other line, it would in fact at some point intersect. So it has to be completely parallel. The converse of this, meaning you kind of flip the phrase so there is exactly one line parallel through a point. It's used to construct parallel lines, and that's actually what we're going to do on the next slide. So what you are going to need is a piece of paper, unless you can print the piece of paper that I did put on to headrush, you're going to want to just be able to draw a line and a point, which I believe you could probably manage. So I did send a package to you that has a ruler. You're going to want to get that out, and then also the compass looking thing. The problem is that I was going to do this by hand, but guess what? I don't have one of those compasses here. So instead, I'm going to use the very traditional looking compass. So if we take a look at this guy here, that one is our traditional compass. A lot of times what happens in real life with these compasses is that the mechanism that holds the top together kind of tends to make it slip. And so the ones that you guys have are actually a lot better for multiple people using them. So what you're going to do if you do not have this actual assignment piece of paper is just take your ruler and draw a line wherever it is. You can make it sloping kind of like mine if you want, and then draw a point anywhere as well. So you're going to take the time to do that. Once you have that done, then the next thing that we are going to do is kind of visualize a little bit. So I'm going to, with my computer abilities here, make a dashed line. So let's see, I'm going to make it thin so we can't see it too well, and we'll make it orange. Okay, so the idea is that, oh, there it is. Okay, the idea is that there's this line that could potentially be parallel and goes through this point that we have, okay? But of course, we don't have that line yet, and so we're going to construct it. So I'm just going to see if I can erase this little end. Yes, I can. Okay, so how do we construct that? We go ahead and get our straight edge, aka our ruler, and we bring it over to the dot that is being used, and hopefully your line also, or your ruler, intersects this line over here somewhere. Okay, so if your ruler is going out like this, not going to work because you need to be able to make what we're calling the transversal line. Okay, let's see if I can remember how this computer program works. Oh, there we go. Woo! Okay, so that is our line. So I've created that uh, intersection here. So now technically what I've made is the line that will create corresponding angles. So for instance, there's a little angle over here, and based on what we know, it should match this little angle that's over here. So now we just need to learn how to copy an angle. All right, so how do we copy an angle? And this is where on your compass it's going to be a little bit annoying because your compass has this little circle thing, right? Okay, and then it has the kind of ruler type thing coming off the end of it. And it's got a little hole. Well, you are actually not going to use any of these little dots that are up here. You're actually going to have to use some of the little dots that are in here because, at least the way that I've made it, I have not made this line long enough. So if you want to, you could actually just get your ruler and make that line longer, and then you could use one of the the extended dots up here. So all you need to do, however, is note that whatever dot you use, you want to like keep your pencil in it or make a mark on it or something. You did all get new compasses, so you probably don't see any of those markings that students have made yet. So what you're going to do is make your compass, the hole that's on the compass on the inner circle, you're going to put onto this intersection. And then you're going to use your you're probably going to want two pencils because one of the pencils is going to hold the center circle on this intersection, and the other pencil is actually going to draw the line itself. So I'm going to change my color here. Nope, green, how about? And I'm going to make a arc. I want to make sure that this arc intersects the line that was provided. Sweet. Now, keeping this at apparently 53 degrees, super, I'm going to go over here and make the same arc. All right, so all I've done is made one arc on the lower corresponding part and then one at this intersection up here. So technically, remember, all we have up here is that one dot that's there. You don't have this dashed line necessarily. You could have estimated it, but again, we don't have that yet, and so now we're going to find that. So, short of using a ruler, which is actually not what you should have a what they call a straight edge, which is just blank. So literally anything that's straight you could use as a straight edge. We are not going to measure between these two. We're going to use our compass to measure between those two. So the idea here is that you're going to set, again, because you have a different compass than mine, you're going to set the center circle on this intersection that we just created. And then you're going to use the outer pieces to identify at which dot you would find that intersection. Okay, so you're going to move this around until you can have the center dot on the intersection and one of the dots along the side at that intersection there. So basically, you're just using it to measure. However, we are not using a ruler for that. Officially, with this one, I'm going to rotate a little bit. I'm going to put this stationary point on the intersection, and then I'm going to rotate and move the arm until it meets exactly at, it's kind of like pinching it here, exactly at that other intersection point, which of course my compass is only a computer, so it's not really allowing me to be completely precise. So I have now officially measured that distance there, and now I'm going to repeat it over here. And again, as awesome as I am, I've almost made that line. That's interesting. And so now I'm making this intersection. So officially getting rid of this made up line that I've made over here. Maybe. I really did try to delete. Let's there. Okay, there. I'm going to now take my ruler, aka straight edge, and I'm going to rotate it so that that point that we originally got or made, let's get a marker of some sort. We haven't used red here. So this original point that we had and this new point that we have just made are going to intersect to make that one parallel line. And again, how did we know that that would work? We knew it because of corresponding angles. So again, trying to make my ruler match between these 2 points, which I'd say that's pretty darn good. And now I'm going to make the line that is parallel. All right, so again, lots of instruction, but just so that we kind of know what happened, the first thing that we did was made this line here that connected the initial point with some sort of intersection on the initial line. Then we repeated this angle. Oops. Then we repeated drawing this angle by making this arc here and then repeating the arc over here. Then we measured the distance between the arc that we just constructed and the line that we wanted to replicate, and then repeated that measurement over here with an arc. Now we have 2 intersection points, 2 points in order to make a line. So the original intersection, or the original point, and then this intersection that we just made. So that doesn't necessarily look exactly parallel, but eyes deceive. Of course, in order to say that something is parallel officially, other than making sure we know this is a line, we could, of course, put the tick mark on it that indicates that. So here's this line is parallel to that line. Woohoo! So this is the parallel postulate, saying that if there is a point and a line, you have the ability via corresponding angles to actually construct that parallel line without using just a ruler or a copy and paste feature. I would go ahead and try that again because construction is actually one of the more fun parts of geometry, and it actually applies that knowledge that we've used. So again, corresponding angles in real life. Oh my gosh. Okay.